Imagine a digital world where trust is built into the very fabric of transactions. This is the promise of blockchain, a revolutionary technology that has the potential to transform the way we interact and do business. At its core, blockchain is a decentralized digital ledger. It's like a public record book. But instead of being held by a single authority, it's distributed across a network of computers. This distributed nature is what makes blockchain so secure. Each block in the chain contains a record of multiple transactions. These blocks are linked together chronologically and cryptographically, creating an immutable record of all past transactions. This means that once a transaction is added to the blockchain, it cannot be altered or deleted. To understand how blockchain works, it's helpful to visualize a chain of blocks. Each block contains a set of transactions, a timestamp, and a unique cryptographic hash. This hash is like a fingerprint that identifies the block and all of its contents. The hash of each block is dependent on the hash of the block before it. This linking of blocks creates a tamper-proof chain. If someone tries to alter a transaction in a block, the block's hash will change. This change will cascade down the entire blockchain, making it immediately obvious that tampering has occurred. This immutability is one of the key features that makes blockchain so secure and trustworthy. Traditional databases are centralized, meaning they are controlled by a single entity. This central point of control makes them vulnerable to attacks and data breaches. Blockchain, on the other hand, is decentralized. The ledger is distributed across a network of computers, making it virtually impossible for a single entity to control or manipulate the data. This distributed nature also makes blockchain more resilient. If one computer in the network goes down, the blockchain remains intact and operational. This is because other computers on the network have a copy of the ledger. Decentralization is a fundamental principle of blockchain, ensuring data integrity and system reliability. In a decentralized system, trust is paramount. But how do you establish trust without a central authority? Blockchain achieves this through consensus mechanisms. These mechanisms ensure that all participants in the network agree on the validity of transactions and the state of the ledger. One of the most common consensus mechanisms is proof of work, or POW. In POW, miners compete to solve complex mathematical problems. The first miner to solve the problem gets to add the next block of transactions to the blockchain. This process requires significant computational power, making it extremely difficult for any single entity to control the network. Another popular consensus mechanism is proof of stake, or POS. In POS, instead of miners, there are validators. Validators are chosen to add blocks to the blockchain based on the number of coins or tokens they hold and are willing to stake. Imagine a world where contracts enforce themselves, eliminating the need for intermediaries and reducing the risk of fraud. This is the potential of smart contracts, self-executing contracts that are stored and executed on the blockchain. Smart contracts are essentially lines of code that automatically execute when predetermined conditions are met. For example, a smart contract for a supply chain could automatically release payment to a supplier once the goods have been delivered and verified. This automation can streamline processes, reduce costs, and increase efficiency. Smart contracts have the power to revolutionize a wide range of industries, from finance and insurance to healthcare and real estate. While blockchain is still in its early stages of development, it is already being used in a variety of real-world applications. One of the most well-known applications is cryptocurrency. Bitcoin, the first and most famous cryptocurrency, relies on blockchain technology to record transactions and manage the supply of bitcoins. Beyond cryptocurrencies, blockchain is being used to create more secure and transparent voting systems. By recording votes on a blockchain, it becomes virtually impossible to tamper with election results. Blockchain is also being used to track products as they move through the supply chain. This can help to prevent counterfeiting, reduce waste, and improve efficiency. Blockchain technology offers numerous benefits, including increased transparency, enhanced security, and improved efficiency. By making transactions tamper-proof and auditable, blockchain has the potential to increase trust and reduce fraud across a wide range of industries. However, blockchain technology also faces challenges. One of the biggest challenges is scalability. As the number of transactions on a blockchain network grows, the time it takes to process transactions can increase. This can lead to slower transaction speeds and higher fees. Another challenge is regulatory uncertainty. As blockchain technology is relatively new, governments around the world are still grappling with how to regulate it. This uncertainty can stifle innovation and slow down the adoption of blockchain technology. The concept of blockchain was first introduced in 2008 by an anonymous individual or group of individuals using the pseudonym Satoshi Nakamoto. Nakamoto proposed blockchain as the underlying technology for Bitcoin, a decentralized digital currency. Bitcoin's success in demonstrating the viability of blockchain sparked a wave of innovation in the field. Today, thousands of cryptocurrencies and blockchain projects are being developed, exploring a wide range of applications beyond digital currencies. The invention of blockchain marked a pivotal moment in the history of technology, paving the way for a more decentralized and trustless future. The future of blockchain is brimming with endless possibilities. As the technology matures and adoption grows, we can expect to see blockchain integrated into various aspects of our lives. Imagine a world where supply chains are transparent and efficient, where voting is secure and tamper-proof, and where digital identities are protected and easily verifiable. Blockchain has the potential to revolutionize industries, empower individuals, and reshape the way we interact with the world around us. While challenges remain, the transformative potential of blockchain is undeniable. As we venture further into the digital age, blockchain will undoubtedly play a pivotal role in shaping a more secure, transparent, and efficient future.